When I first started this video series on Design a CPU, one of the dreams was to get to the point where I could render the Mandelbrot set on the screen using the CPU. So that's what we're going to do today, and this is really a milestone for this full video series. We're now on Design a CPU 4. We've still got one more course to go where we look at the compiler, but this is a point, a memorable point within the entire series. So if you head into the ASM folder and you head down to, there's a couple of files there, one called Mandelbrot LD for low definition and Mandelbrot HD for high definition. Now again, these pieces of code were written by Timothy Morgan, and as I speak at this moment, I think he probably wrote these possibly a year or so ago, and I was really pleased whenever I seen these rendering on the machine. It was really quite fantastic, and I always said I want to get to the point where I've got the machine and all the video series to catch up with this. So that's where we are today. Now what we'll do is we'll first of all look at the low definition, and before we go through the code and have a look at the code in more detail, what we want to do is just show you what the final outcomes of these pieces of code are going to be. So what we can do, we'll go terminal, run task, and we'll assemble the file first just to check and see that everything is running okay, and you can see it says assembly successful. And then we can run the emulator. Now the reason for running the emulator is that it probably takes this code many hours to run. Even the low definition one will take many hours to render. So that's us ran up the emulator, so we can run it with R. So that's it finished now, and we can do a graphics dump. So GD for graphics dump, and that's the whole emulation finished. So what we can do now is we can load it into our machine. So if we go to the motherboard, and the first thing we want to do is open up the splash screen. So we're in the MC folder, and you can see we've got this file here called splash. So we'll open this up, close it, and then within the graphics 2 unit, we'll open this up and we'll load in the actual graphics data. So that is graphics.dat. So this is in the RTM16 parent directory called graphics.dat. So we'll open this, and that's us got the graphics for the Mandelbrot set loaded. Now we can close this again, and we'll go into simulate, tick enabled. Now if we head down in, you can see within the graphics unit here that it is actually counting through, and it'll take a minute or two for it to render the entire Mandelbrot set onto the screen. So what I will do is I'll stop talking and I'll fast forward this video, and I'll get you at the end of the simulation. So that's the Mandelbrot set finished rendering, and as you see, it's symmetric about the x-axis. Now don't worry too much if you don't know what the Mandelbrot set is or what this is all about. We'll have a wee talk about it whenever we look at the actual code. So what we can go on to now is we'll actually have a look, and we'll see the Mandelbrot set rendered in high definition, not within our CPU, but just within pictures that are freely available within any web browser. So if you head into a web browser and type in Mandelbrot Set, and we'll look at some of the images. So this is the kind of basic image that we are looking for. And in fact, you can generate an image similar to this here within a graphical calculator called Desmos. And as you see, you can keep zooming in, and the detail is absolutely fantastic. Now there's plenty of these videos available online, so you can go in and have a look at it. And this is within Wikipedia, and you can see these fantastic videos. But all we're going to really have is what we've seen at the beginning here. So the image that we had here. So we're looking for something that looks kind of like this. Now that's what we've got, but obviously the image we've got just now is low definition. It's a bit rough and ready. So let's have a look at our high definition version. Now let's look at the high definition version. So if you click on Mandelbrot HD, and we will assemble it first of all, make sure everything's okay. And you see it says assembly successful. Terminal, run task, and we will emulate the file. So that's the emulator ran up, and we can type in R for run. So that's it finished, and we type in the GD for graphics dump, and then we can get into our CPU, and we'll get into the RAM, and we'll open up the splash, and then we'll get into the graphics 2, and we'll load up the RAM with the graphics data. So that's the graphics.dat, and that's us got everything available to us here. So we'll close this window and we can start running the splash screen. So that's it started running now, and we'll just wait here and we'll see exactly how this is going to render onto the screen. And you can see it's relatively quickly rendering, and it maybe take about a minute or so for this to completely render. So that's our high definition Mandelbrot set now rendered. So let's have a little zoom in and we can get a better look at it. So considering that we started off on Design a CPU course with AND gates and OR gates and just the basic logic of digital circuits, we were able to build up within 4 courses a fully functioning CPU that will allow us to write the assembly language code which will display the Mandelbrot set onto the screen. So this is a fantastic spot to get to within the whole of our series on Design a CPU. So again, let's compare our high definition image with an actual image online. So we'll type in Mandelbrot Set, Brot Set, okay, yep. and we'll put in the images. So let's see if we can find something similar. So this looks like something similar to ours. Okay, so we can see the image that we have here, and we can see the image that we have generated. So it's really quite cool, and I'm really pleased that we're able to get to this point within our Design a CPU 4 course. Now, I said we're going to go over the code and a little bit of the mathematics, but I think what we can do is we'll leave that until the next video, and we can just leave this as a nice, interesting, fun video without all of the details. So thank you for listening. I'll get you on the next video. Goodbye.